Alright, so I think this is recording. Let's see, we've got Tarzan is swinging on a vine that is hanging from a tree branch, going back and forth alternately over land and water. Jane starts a stopwatch. When X is 2 seconds, Tarzan is at one end of his swing, 23 feet from the bank over land. When X is 5 seconds, he's on the other end of his swing, 17 feet from the riverbank over water. Assume that while Tarzan is swinging, his horizontal distance from the riverbank varies sinusoidally with time. Write an equation for the distance from the riverbank as a function of time. Alright, so let's see. We've got this water. We've got this riverbank. And on this riverbank, somewhere is some kind of a tree that is going to have a limb that goes over this riverbank. And we've got some type of a vine, or I'm just going to make it look like a rope around the branch. Let's see. Now, wait a minute. Alright. So this is here, and this swings back and forth. So it swings, and this swings. So, alright. we've got Tarzan that's swinging back and forth on this vine. So now this isn't to scale very good because the distance from the riverbank to at one end of the swing, 23 feet from the bank over land. So this is 23 feet over land. And the way I've drawn it here, the 23 looks shorter than the 17 feet, but we get the idea. All right. So this is really our zero. And so we want to um, have the maximum, the way I've got it set up here, being positive 23 feet, because you're 23 feet to the right from the bank, and then from the left of the bank, that would be negative 17 feet. And if we add that together and divide by 2, if we take 23 plus a negative 17 and divide that by 2, why am I dividing half of 6 is 3? Alright, so we've got that. Now, at 2 seconds, he's at one end of his swing 23 feet. So if we call this point that he's at his max, which is 23, that's at 2 seconds. Then in 5 seconds, he's at the other end of his swing, which we're calling a minimum, negative above the water. Alright, so 5 minus 2 is 3, and that's one period, or half of a period. So if half of a period is 3 seconds, then a full period is 6 seconds. And half of 3 is 1.5, so this would be 3.5. And then 6.5, then add 1.5, you're at 8. Yeah, okay. So there's what we have now. Do we want to use the sine curve? So we want to pick a point on the center line and pick a point so that we don't have to deal with the negative sign with a reflection. So we could pick this point, or and talk about that first cycle to there, or we could pick this point at 6.5. So let's see if the problem recommends. Uh, that's the previous problem. What about how long in seconds until Tarzan is at the center line for the first time? So if I back up 1.5, so this is 0.5 at the first time, right? Because then if I add 1.5, I'll be at 2. So yeah, so we'll use this guy because that's a positive value. We'll use from here to here as our basic cycle. Well, I'm going to have to erase Tarzan. It's not letting me shrink it. There we go. It didn't have the whole tree. If we cut the limb off, Tarzan is definitely going to fall. All right, Tarzan's got to go. Tarzan beaten by an eraser. All right. So the amplitude, 23 minus 320. 2 pi divided by the period. The period is 6 because you can see the distance from 0.5 to 6.5 is 6. We've shifted it to the right, so that's a subtraction because it's bizarre in its behavior. And the center line is 3. And 2 divided by 6, we can write this as pi over 3. Reduce this as pi over 3, and we're done. So there you go, and I hope that helps. Talk to you later.